Hello, this is Robert, and in this video I would like to discuss GDB, the GNU debugger. So I'm in my multi-file project directory, and so this project contains 3 different source code files. We have main.cpp, which calls add them and sub them. And then we have 2 other source code files that contain the definition of these functions. And then we've also included our header.h file right there. So let's go ahead and take a look at add them, which is in function1.cpp. So cat function1.cpp. And then we have sub them in function2.cpp. Okay. So when we compile these source code files together, they are compiled and linked into one executable program. If we want GDB to be able to tell us what each line of code is doing, we have to include a symbol table when we compile the program. So let's list our files one more time. And so let's take a look at the make file, and we can see that the -g flag is included when we do compilation. And that means that it will include the symbol table, which contains our source code file, so we can actually see our source code file when we are debugging. If we would like to compile on the command line, we can just say G++. And then we can give it the -g flag, and then we can just list the source code files that are part of the project. So function1, function2.cpp, and main.cpp. And then I'll give it the name program. Okay, so it compiled our program. And it included the symbol table so that GDB can let us know what's going on each statement. Let's go ahead and run program. Oops. Okay, /program, and it just asks for 2 numbers. So how about 5 and 4? 5 plus 4 is 9. 5 minus 4 is 1. Okay, to see this code in action, we can start up the GDB debugger, the GDB, the GNU debugger, and then we just list the program that we want to debug. Okay, so now I can list the statements with L, or I can type list. L and list do the same thing. If I type L again, then it will continue to list the statements in the source code file. So now I can see line 11 down to 17. 17 is the last statement in the source code file, so if I list again, it says there are no more statements to list. If I'd like to go back up to the top of the source code file, I can say list 1, and then it starts listing again. If I say, for example, list 10, then it will give me the 5 statements above line 10 and the 5 statements below line 10. So I get to see line 5 and then down to line 14. So I guess it's showing me the 4 lines after the line number that I wanted to list. Okay, so I guess the idea is that if I list a line number, it appears in the middle of the lines above it and the lines below it, and it'll give us 10 different lines. All right, so let's go ahead and switch to the text user interface mode so that we can have a better view of our source code, and we'll be able to have a better view of what's actually going on when our program runs. All of the commands that I'm going to be using in text user interface mode are available in command line mode. There's a difference, though, in the way that the up and down arrows work in the two separate modes. Now that I'm in command mode, I can just type the up arrow key, and this is sort of like the Linux command line, right? I can go back to the commands that I gave it previously. If I want to go into text user interface mode, I would say TUI and then enable. So now I've enabled text user interface mode. And then when I list, I get to see the statements up here. And now I am using the arrow keys to go up and down. And so now instead of going back to my previous commands, I get to scroll up and down to see the source code file. Remember that there are 3 separate source code files, and so if I would like to see the other source code files, there are a couple of ways to do it. If I know the names of the functions in those source code files, then I can list the function name. So if I would like to list add them, it will jump to function1.cpp. And then if I list sub them, now it jumps to function2.cpp. The other way to jump to different source code files is just to name them and then list the line number that you would like to jump to. So I can say list main.cpp, then a colon, and then line 1. So now I'm back to the main.cpp file. I can say list function1.cpp line 1, and then it jumps to function1.cpp. So there are a couple of ways to change source code files. Let's go ahead and jump back to main.cpp. So list main.cpp line 1. Okay. The program is not running yet because we haven't set a breakpoint and we haven't told it to run yet. If I would like the program to run without a breakpoint, I can just type R, or I can type run. Okay, so type return, and then it's running. Give me 2 numbers to add and subtract, 5 and 4. And so now it says that it exited normally. Okay, so it didn't crash, and there were no problems that GDB could find. So now if I want to run it again, I would just type R again. Okay, notice that the text user interface window got a little bit mixed up. So when that happens, you can usually scroll up and then scroll back down, and then the window will reset itself. The other trick that you can do to have the window reset itself is just grab the edge of the terminal and move it just slightly, and then that will cause the GDB to redraw the window as well. So if it really gets screwed up, just grab the terminal window and just move it in or out just slightly, and it will redraw itself. Okay, so let's go ahead and take a look at setting a breakpoint. So if I would like to set a breakpoint, I can either name the function that I would like to set the breakpoint on. So I could say break, or for short, I could just use B. And then if I'd like to set a breakpoint on main, I can just list that function. And notice that it put the breakpoint on the first executable statement that's part of main. If I would like to put a breakpoint on add them, I can just name that function as well. So list add them now, and we can see that there's a breakpoint on the first executable statement of add them now. Okay, so list main. Notice that we have B plus over there. So it's lowercase b, meaning that we have a breakpoint that hasn't been hit yet, and then we have a breakpoint set there. There are 2 ways to clear a breakpoint. The first way is to specify the line number. So we can say clear, or CL for short. So CL and clear do the same thing. And then I can specify the line number that I want to clear the breakpoint from. So deleted breakpoint 1. Notice that there's still a B plus there, but if we scroll up or down, it will go away. Okay, so now we have another breakpoint in add them. So let's go ahead and take a look at that source code file one more time. So list add them. And we have a B plus on line 7. The other way to delete a breakpoint is to delete the breakpoint number. So let's go ahead and do info breakpoints. So if we want to see a list of our breakpoints, we can say info breakpoints. We have breakpoint 2 on line 7 of function1.cpp. So the breakpoint number is 2. So if we say delete breakpoint 2, then it will delete that breakpoint. So if we do info breakpoints one more time, we now have no breakpoints. And then I can scroll up or down, and it will refresh the window, and that B+ went away. Okay, we have to have at least one breakpoint in order to run our program and have the code stop for us. So let's switch back to the main function, and we'll put our breakpoint back on line 9. Okay, so now we have a breakpoint, and then when I type R, it's going to run, and notice that it stopped on line 9, and we can actually take a look at what's going on. So we often want to know what our variables contain at any given time. So we have num1, num2, result, and word. So what I can do is, if I want to see all of them, I can say info locals. So those are local to this frame. And we'll talk a little bit about what the frames are a little bit later. So we have basically garbage in our variables because I didn't set them to any values, right? Let's say I would only like to see, let's say I'd only like to see the variable result. What I can do is I can say print result. So P is short for print. I can type it out if I want to. Or print num1, for example. Okay, basically they contain garbage. If I would like to execute line 9, all I have to do is type N, and that stands for next. So I can either use N or I can type next. So now we did string copy hello into Word. So let's take a look at Word again. So print Word. Notice that it gave us the hello C string that we were interested in. And then here's the null terminator. So whenever we use, well, actually this C string is null terminated, but it's giving us a lot of garbage here. So we had a C string that's 128 characters, but we really are only interested in HELLO and the null terminator. So we are really only interested in those 6 spots in the C string. So if we would like to see a better view of this C string with all of that, without all of that extraneous information, we can type set print null stop. So that causes GDB to stop printing when it sees the first null terminator, which is right there. So now let's print Word one more time, and we can see that it just gives us the characters that we're interested in. Let's do info locals one more time, and we can see that num1, num2, and result are still garbage, but Word has been set to the word hello. Okay, so let's go ahead and execute the next line, line 10. And so it gave us, it actually executed, please give me 2 numbers to add and subtract, but it's waiting to send that to the screen just for efficiency's sake. So sometimes when we're running our code in the GDB debugger, we don't get to see all of our output statements right away. But when I execute the next line, it actually will output that statement for us. So next, one more time. Please give me 2 numbers to add and subtract, 5 and 4. Okay, so now we're on line 12. This is a function call, right? So I can type N, and it will treat that statement just like one statement, and then it will go down to line 13. It looks like we have a garbled window again. So the first step is to scroll up and then scroll back, or scroll down and then scroll back up. And that worked to reset it. And as I said before, you can just grab your terminal window and resize it a little bit. Okay, so let's type n so that it treats it like a single statement. Oh, by the way, if I want to just repeat the last command, I don't have to repeat it. I can just type return, and that will execute n for us. So we called add them, and it ran, and then it came right back. So then the next statement is line 13. I typed 5 and 4 for num1 and num2. So let's take a look at those new variables now. Result was set by add them as well. So if we do info locals, we can see that num1 now contains 5, num2 is 4, and result is 9. Let's execute the next statement. And then let's say that we would like to see the function in action. So we would like to jump to the function and see it in action. Instead of typing n for next, what I want to do is type s for step into. So s will cause the code to step into the function that was called. Okay, so now there's only one statement in that function, and so we can see that line 7 is going to run. There are no local variables, so if I say info locals, there are no locals to this function. Let's say we would like more information on the info statement. What we can do is we can say help info, and we can type help on just about anything we want. So we could say help list or help info or whatever is available. So let's do help info. Okay, so info address, info all registers. If we were trying to debug maybe our program that was written in assembly, we could take a look at the registers. Info args, argument variables of the current stack frame. Well, that's the one I'm interested in because I'd like to see the value of n1 and n2. So let's go ahead and type q return. So now we quit the help screen, and then I can say info args. So we can see that n1 is 5, n2 is 4. So we can see the values that were passed into the function. All right, so then we can just continue running the program. Let's say we have seen everything that we need to see about our program, so I can just type C for continue, and it output 5 minus 4 equals 1, and then the program exited normally. Let's take a look at another feature that we can have with GDB, and those are called Watchpoints. So sometimes we don't necessarily know when and where something is going to happen, but we know it is happening in our program somewhere. So instead of setting a breakpoint on a line number and hoping that we get to see what it's doing, we can set a watch point. Sometimes variables take on values that we don't want them to take on, and so we want to watch for that particular value. Sometimes there's a value for a variable that we do want it to have, but we don't know where it's going to happen, and so in that instance we need to set a watch point. Okay, so let's start up our program again with R for run, and it hit the breakpoint on line 9. So what I want to do is I want a breakpoint that is going to tell me when num1 takes on a certain value. Let's say, for example, that I would like to know when num1 is equal to 5. So what I can say is I can say watch num1 equal to 5. So now I have a watch point. I can take a look at my watch points with info watchpoints, or I can say info breakpoints, and then it will give me both breakpoints and watchpoints. So I have a breakpoint on line 9 of main, and then I have a watch point that's watching num1 to see when it's equal to 5. So let's go ahead and continue. And then when it asks me for the two numbers, I'll say 5 for num1 and 4 for num2. Okay, so it hit my watch point. So it's telling me that hardware watch point 4 num1 equals 5 was hit. So num1 did become 5. So there are a lot of times when we want to take a look at the state of our program, and so it hit that watch point, and so I can do info locals right now, but I'm not going to get what I would expect. Okay, so let's go ahead and take a look at the frame. So if I say frame, it's going to give me the frame of the currently executing function. And so when we did cin, it actually called several functions in a row. So there are several frames, one for each function that was called. So let's do info. Okay. So we can see that we are not in the main function frame, which contains the variables that we would like to see. So what we can do is we can say backtrace. So we can type bt to see the function calls, the frames that go along with each function call. So the current frame is 0, and that is this function right here, and this is part of cin. And then before that, this function was called, and so there are about 4 different functions that were called. So we have 0, 1, 2. So we have numGet. That's the frame for 2. And then once we finally get back to main, that is frame number 4. So if we would like to see a different frame, we can say frame 4, and then I can say info locals, and that will give me the local variables for frame number 4, which was main. So every time a function was called, it created a new frame. And so currently we are in frame 0, which is this function right here. Convert to v, I guess, is what this particular function is called, and it's part of the cin object. Okay, so what we can do now is we can just continue. Okay, so if you would like to see the variables that caused the watch point to happen, or caused your program to stop on that watch point, just switch to the frame. So frame 4 contains the variables that we're interested in, and then I can say info locals, and then I can see that num1 was equal to 5, and that's what caused the watch point to trigger. Okay, let's just go ahead and type continue from here, and so then our program terminated normally. Let's go ahead and quit, and then let's go ahead and take a look at how we can start up GDB so that it is automatically in the text user interface mode. So I can give it the -TUI flag, and then when it starts up, it's automatically in text user interface mode. Okay, I think that I have covered about everything that I would like to cover about GDB. Well, maybe I mentioned this before, but if I would like to go back to command mode, I can say TUI disable, and then I can go back to the command mode. Okay, thanks for watching.